Welcome to Introduction to Building Codes. This presentation is based on the Bangladesh National Building Code 2020, BNBC 2020, Part 8 Building Services, Chapter 2, Air Conditioning, Heating, and Ventilation, Part 2 presentation. The description of this presentation is designed to familiarize and assist code officials, inspectors, engineers, designers in not only locating the code sections, but describing and applying the applicable code requirements for air conditioning, heating, and ventilation systems. The overview. Internationally, code officials recognize the need for a modern, up-to-date mechanical code that addresses the design and installation of mechanical systems through requirements emphasizing performance. This presentation will cover key topics of the following areas: terminology, air conditioning equipment, and exhaust systems. Terminology is key to understanding the requirements and the applicability of this code. We will spend a little bit of time and go over key terms regarding air conditioning equipment and exhaust systems. The seminar goal is the following. The goal of this training is for you to learn and apply key code requirements contained in Chapter 2, Air Conditioning, Heating, and Ventilation, to enhance your performance while inspecting these systems. This training will also provide participants with specific code requirements, along with examples related to design, installation, and inspection of air conditioning, heating, and ventilation systems to further enhance your knowledge. The objectives. Upon completion, participants will be better able to understand terminology as it relates to air conditioning equipment and exhaust systems, locate applicable code sections and standards for specific situations, apply code requirements to real-world situations, explain the intent behind a given code requirement, use good judgment to identify certain systems and related components as compliant or non-compliant. Section 2.4, Terminology. Terminology is key, ladies and gentlemen. We need to specifically understand certain words, or maybe even a single word within a code section to fully understand the intent of the code. So it's very important that we understand the language of air conditioning, heating, and ventilation. This section provides an alphabetical list of the terms used in and applicable in this chapter of the code. In case of any conflict or contradiction between the definition given in this section and that in Part 1, the meaning provided in this section shall govern for interpretation of the provisions of this chapter. Now, a code provision could be misinterpreted if the definition of a term as used in the context of the code is not understood. This reinforces why we need to understand the terminology for air conditioning, heating, and ventilation systems. The following slides will provide key definitions that will assist the code user to properly understand certain terminology related to this chapter. Codes, by their very nature, are in fact technical documents. As such, literally every word, term, and punctuation mark can add to or change the meaning of the intended result. This chapter contains several terms that are important to understand the provisions of this code. Definitions are found both in this chapter and throughout the code. Let's look at some key terminology relating the air conditioning, heating, and ventilation systems. The term air conditioning has a very specific meaning. Air conditioning is the process of treating air so as to control simultaneously its temperature, humidity, purity, distribution, pressure, and air movement to meet the thermal requirements of the space. Below is an example of a variable air volume box with a chilled water coil that provides temperature and humidity control to a zone within a building. It also provides the distribution, pressure, and air movement along with the temperature and the humidity to condition the space that it supplies. The key topic here is all of the above meeting the requirement and terminology for air conditioning. Additionally, upstream we would find filtration to guarantee the purity of the air being filtered adequately as well. Air handling unit is defined as equipment comprised of cooling and/or heating coil and a blower or fan with electric motor used for the purpose of cooling, heating, and distributing supply air to a room, space, or area. Below is a picture of an air handling unit. This air handling unit is equipped with chilled water and hot water supply in return. The term condensing unit. A condensing unit is a complete set consisting of compressors, condensers with or without receiver. It may be air-cooled or water-cooled. Below is an example of an air-cooled condensing unit. A condensing unit subcools the hot gas produced from a compressor and changes the state from a hot gas to a liquid by the time it gets to the bottom of the coil. So a condensing unit actually provides subcooling. Cooling tower. An enclosed device for evaporatively cooling water by contact with air. The cooling tower in the diagram below is as follows. As you can see, we have a water reservoir at the very bottom of the cooling tower. The water reservoir must be at a certain level to allow the pump to draw in water on the inlet side of the pump. The pump pumps the water through the supply into the heat exchanger where it goes through a heat transfer process, thus cooling down the condenser portion of a chiller. Upon being cooled down, the water picks up the heat from the condenser in the chiller, and we have the warm water outlet of the heat exchanger that is piped to the nozzles on the top of the cooling tower. The nozzles spray this warm air in direct contact with airflow coming from the fan power of the cooling tower. This process evaporatively cools the water by contact with air. So the water finds its way back down into the water reservoir, and the process starts all over again by taking the water through the pump, through the heat exchanger, and up through the top into the nozzles. The water reservoir must be at a certain level, not to be below the pump level. Therefore, by evaporation due to the atmosphere, Makeup water is required, and as you can see on the left-hand side, we do have a makeup water supply to keep the water reservoir at that precise level to keep supplying water to the process to cool down heat exchanger and chilled water condensing water. The term packaged air conditioner is an encased assembly of equipment, machinery for thermal conditioning of cooling or cooling and heating of air, along with cleaning and circulation of air to maintain internal thermal environment of air-conditioned space. It includes a prime source of refrigeration for cooling and dehumidification, with or without internal and external air distribution ducting. It may also include means for heating, humidifying, and ventilating air. These units may be floor-mounted, wall-mounted, or ceiling-mounted types. They may provide free cooling or ducted delivery of conditioned air. These machines are equipped with air-cooled or water-cooled condensers. These machines are equipped with reciprocating, rotary, or scroll-type compressors. Below is a packaged heating and cooling unit that provides all of the heat transfer effects for a conditioned space. It also provides filtration as well, and external ductwork can be connected to this particular packaged heating and cooling air conditioner to have the air distributed to the spaces within the building. Chapter 2, Section 2.9, Air Conditioning Equipment. This section governs the approval and installation of air conditioning equipment and appliances that are regulated by the code. A fundamental principle of the code is its dependence on the listing and labeling method of approval for appliances and equipment. Additionally, this section contains requirements for the safe and proper installation of mechanical equipment and appliances to ensure protection of life and property. We will go over specific equipment, key requirements of this code for specific equipment and appliances. Section 2.9.1.2 gives us a requirement for approval. When required, each appliance shall be approved by the building official for safe use or comply with applicable nationally recognized standard. For this purpose, installers shall furnish satisfactory evidence that the appliance is constructed in conformity with the requirements of this code. The permanently attached label of an approved agency may be accepted as such evidence. The code is a compilation of criteria with which appliances must comply to be suitable for a particular application. The code official has a duty to evaluate such appliances for code compliance and nationally recognized standards. This gives the authority the right to observe, require, and approve appliances that are applicable for their end use, for safety and verification that the testing and listing requirements are quite evident for safety of life and property. Now, section 2.9.1.3 is the labeling section, and it states that all mechanical equipment and appliances shall bear permanent and legible factory applied nameplate on which shall appear construction and operation data, including safety requirements. Now, the product label is the primary, if not the only, assurance to the code official that the appliance is safe for installation. So this language is pretty important that we realize that all equipment and appliances must bear the label. Section 2.9.1.4 gives us a requirement for testing in our code. Where required, an approved agency shall test a representative sample of the mechanical equipment or appliance being labeled to the standard or standards pertinent to the equipment or the appliance. The approved agency shall maintain a record of all tests performed. The record shall provide sufficient detail to verify compliance with the test standard. The approved agency is essentially responsible for maintaining a record of specific information concerning the product tested, as well as the results of the tests performed. In order for a piece of equipment or an appliance to undergo testing, there are certain test standards based upon the applicable product. Those specific tests have to be performed, and the approved agency is responsible for maintaining a record of these particular tests. The test standards detail what information is important to record. The records provide proof that the testing was actually performed and that the appliance or equipment met or exceeded the minimum requirements of the applicable product standards. Before an appliance or other component can be labeled, the code requires specific actions by qualified agencies and personnel. Going back to section 2.9.1.4 testing, this describes the requirements specifically that must be compiled before a label can be issued for the appliance or the equipment. Below is an example of a label. The labeling of an appliance ensures that testing in compliance with an applicable standard has been performed and that the product will perform acceptably where installed and operated in accordance with the appliance's listing. The label is an indication to the installer, the inspector, and the end user that a similar appliance has been tested and evaluated by an approved agency and has been determined to perform safely and effectively when installed and operated in compliance with its listing. Figure 1.1 below shows an example of a label for a condensing unit. When we observe the label by inspection, on the label we can see information that is pertinent to the authority, to the inspectors, and to the owner and maintenance personnel. We have the model number of the condensing unit, we have the serial number, we have the manufacturer date, the voltage, the phase, the hertz, which is cycles per second, the minimum circuit ampacity, overcurrent protection device, the maximum fuse size, and the type of refrigerant that the condenser uses. And of course, we have a AHRI certified label on the nameplate accordingly. Not only does it give us that information, but it also gives us the compressor motor, running load amps, and full load amp as well. Section 2.9.1.6 gives us a requirement for access, air conditioning equipment access. And it indicates that all mechanical equipment and appliances shall be accessible for inspection, service, repair, and replacement without removing permanent construction, unless otherwise specified. Not less than 750 millimeters of working space and platform shall be provided to service the equipment or appliances. Appliance controls, gauges, filters, blowers, motors, and burners shall be accessible. The operating instructions shall be clearly displayed near the appliance where they can be read easily. Now, because appliances require routine maintenance, repairs, and possible replacement, access to appliances is required. We need to be able to provide plenty of space for service personnel and repairs to be made on permanently installed appliances. Therefore, the access to the appliance must not also require removal or disconnection of any other appliances, ducts, piping, or vent systems associated with other appliances. The intent of this particular section of the code is telling the code user that we cannot provide any permanent appliances, equipment in the area of the appliance requiring service. We need a clear space, approachable, and large enough for the service personnel to work on and maintain, repair, or replace the permanent appliance. An access example is indicated below. An appliance or piece of equipment is not accessible if any portion of the structure's permanent finish materials, such as drywall, plaster, paneling, built-in furniture or cabinets, or any other similar permanently affixed building component, must be removed. Not less than 750 millimeters of working space and platform shall be provided to service the equipment or the appliance. Figure 1.2 shows an example of appliance access. As seen here, we have a service side of the appliance, and we maintain a platform and minimum dimensions for serviceability of the permanently installed appliance. Section 2.9.1.7 gives us further information regarding location. A, remote location. Where an appliance is located in a remote location, a walkway having a minimum width of 600 millimeters shall be provided, leading from the access opening to the appliance. B, hazardous location. Appliances installed in garages, warehouses, or other areas where they may be subject to mechanical damage shall be installed behind suitable protective barriers, or at a suitable height above the floor, or located out of the normal path of vehicles to guard against such damages. Air conditioning or heating equipment located in a garage and which generates a glow, spark, flame capable of igniting flammable vapors shall be installed in such a way that the pilots and burners or heating elements and switches are at least 450 millimeters above the floor level. As an example, the elevation of an appliance in a garage is indicated in figure 1.3. This provides an example of elevating an appliance's ignition source at least 450 millimeters above the garage floor. This will effectively prohibit the flammable and combustible liquids that give off vapors that are more dense than air to collect near the sources of ignition. So in order to elevate the appliance, we are being above that threshold elevation. The accumulation of flammable vapors more than 450 millimeters deep is unlikely in most ventilated locations. Therefore, maintaining all possible sources of ignition at least 450 millimeters above the floor will substantially reduce the risk of explosion and fire. Lastly, the 450 millimeter value is a minimum requirement and must be increased when required by the manufacturer's installation instructions. Section 2.9.1.7c is titled Outdoor Installation. When we have mechanical appliances that are located outdoors, the appliances and the equipment must be listed for outdoor use. This section gives us the requirement for outdoor equipment and appliances. It states the following: mechanical equipment and appliance located outdoors shall be approved for outdoor installation. Therefore, appliances installed outdoors must be specifically listed for outdoor installation. If an appliance is not labeled for outdoor installation, it must not be installed outdoors because of the risk of malfunction and accelerated deterioration from weather and ambient temperatures. The manufacturer's instructions and listing must be consulted to determine whether a particular appliance is designated for or can be made suitable for outdoor installation. As seen in the picture below, there is a compressor room that is listed for outdoor usage, and it has condensing units installed above the compressor room accordingly. All of the appliances and equipment in this installation are in fact approved for outdoor use. Where appliances are located within 3 meters of a roof edge or open side of a drop greater than 600 millimeters, guards shall be provided. Height of the guards shall be a minimum of 900 millimeters and a maximum of 1,050 millimeters above the surface. The requirements of this section are intended to protect personnel from the hazard of falls during all conditions. This section pertains to appliances regulated by the code that require routine inspection, maintenance, and repair, and also replacement of appliances and equipment accordingly. As seen in the graphic below, we have a rooftop installation. We have an air conditioning appliance that is within 3 meters of the roof edge, and this installation will require guards as indicated above. The height again of the guards as shown here shall be a minimum of 900 millimeters and a maximum of 1,050 millimeters above the surface. Condensate wastes are given to us in section 2.9.1.9 as a requirement for proper piping and proper discharging of condensation from our air conditioning appliances. And it states that condensate from air cooling units along with fuel-burning condensing appliances and the overflow from evaporative coolers and similar water-supplied equipment shall be collected and discharged to an approved plumbing fixture and disposal area. The waste pipe shall have a slope of not less than 1 in 100 and shall be of approved corrosion-resistant material, an approved size. Condensate or wastewater shall not drain over a public way. Condensate waste must be conveyed from the drain pan outlet to an approved place of disposal. They must be constructed of corrosion-resistant materials and sized appropriately. The piping needs to be corrosion-resistant due to the fact that we don't want any rust or inhibited type of corrosion on the inside of the piping that will limit the flow area within the piping. All horizontal sections of the drain piping must be installed in a uniform alignment as well, and slope not less than 1 in 100. The figure on the right side of the slide indicates piping that is installed as a condensate waste system from the appliances indicated on the upper level. The piping is run from the drain pan outlets of the equipment and the appliances down the wall and discharges to an approved location, being installed with corrosion-resistant materials. Section 2.9.2.3, Access for Cooling Units. Item A. Except for piping, ducts, and similar equipment that does not require servicing or adjusting, an unobstructed access and passageway not less than 600 millimeters in width and 2 meters in height shall be provided to every cooling unit installed inside buildings. This is necessary, again, for servicing, repairs, replacements. The access opening to a cooling unit located in an attic space, however, may be reduced to 750 millimeters in length and width, provided the unit can be replaced from its opening or other opening into this space or area. So the exception provides a limitation such that you don't have to go with the full height of 2 meters as long as you've got acceptable working space located in the access space to the attic to maintain this minimum criteria. Section 2.9.2.3, Item B, Attic or Referred Space Installation. The access to and working platforms for cooling units or cooling system compressors located in an attic or referred space shall be provided with a solid continuous flooring, not less than 600 millimeters in width from the access opening to the required workspace and equipment platform in front of the equipment when access opening is located more than 1 meter away from working space. This gives a requirement that we have to have a solid floor in an attic space such that the service personnel, maintenance people can traverse or walk on the floor in the ceiling area or crawl to the appliance or equipment requiring service. Now there's an electrical requirement as well here. Given to us in section 2.9.1.8, item A, equipment regulated by this code requiring electrical connections of more than 50 volts shall have a positive means of disconnect adjacent to and in sight from the equipment served. This is very important that we have an electrical disconnecting means to the equipment requiring service. A 230 volt AC grounding type receptacle shall be located within 8 meters of the equipment for service and maintenance purposes. The receptacle need not be located on the same level as the equipment, and low voltage wiring of 50 volts or less within the structure shall be installed in a manner to prevent physical damage. The low voltage wiring of 50 volts or less may be the thermostat wire, control wiring for the air conditioning equipment. Item B in the electrical installation section indicates that permanent lighting shall also be provided to illuminate the area in which the appliance is located. For remote locations, the light switch shall be located near the access opening leading to the appliance. There is an exception. Lighting fixtures need not be installed when the fixed lighting for the building will provide sufficient light for safe servicing of the equipment. Not only do we have to have safe access, enough access for servicing the appliance, but we also have to have a receptacle and a lighting fixture at the location of the appliance for the service personnel accordingly. An attic installation is given below. As you can see to the lower right-hand side of the slide, there is an access opening large enough to remove the largest appliance. We have a light switch that provides control of a permanent lighting fixture located near the appliance. We have a working platform in front of the equipment, as shown in the upper left-hand portion of the graphic. The permanent lighting shall be provided to illuminate the area in which the appliance is located. As seen here, we've got a lighting fixture or a luminaire in this particular location where the service personnel can clearly see the appliance and provide enough illumination for servicing of that appliance. For remote locations, the light switch shall be located near the access opening leading to the appliance. Therefore, as we can see again at the access opening, we have the location of the light switch. Finally, the solid continuous flooring, not less than 600 millimeters in width, is required from the access opening to the working space and platform in front of the equipment or the appliance when the access opening is located more than 1 meter away from the working space. In this example, the appliance is further than 1 meter away from the working space. Therefore, we must have the solid continuous flooring from the point of the access opening to the working platform of the equipment. Section 2.9.2.3, Item C, filters, fuel valves, and air handlers. An unobstructed access space not less than 600 millimeters in width and 750 millimeters in height shall be provided to filters, fuel control valves, and air handling units. Refrigerant, chilled water, and brine piping control valves shall be accessible. This section lays out that there is also access requirement for this type of equipment: filters, fuel valves, and air handlers. The air handling unit is given to us in section 2.9.5. Specifically, access to the air handling unit is specified as a requirement in this code in section 2.9.5.3 and states the following: floor area of the air handling unit room shall be sufficient to allow proper layout of equipment with adequate access space and working space for proper operation and maintenance. As can be seen to the right, we have an air handling unit, and there is plenty of space for servicing of all parts of the air handler, and this allows proper layout of the equipment and the appliances for servicing, maintenance, and replacement of the equipment and appliances that make up the air handling unit. Installation requirement is given to us in section 2.9.5.4 and states the requirement as air handling units shall be installed on vibration isolators to restrict transmission of vibration to the building structure. This is important, especially when we have blower motors, things of that nature that transmit vibration to different parts of the structure. Vibration isolators are required here to prevent or dampen the vibration at the unit to prevent reverberation into the building structure. The base of the air handling unit shall be a minimum of 75 millimeters above the adjoining floor level. In other words, we need to elevate the equipment accordingly for corrosion protection, allowing air to move underneath the appliance, and for cleaning purposes as well in the mechanical room, such that there is a space underneath the air handler. Finally, all air handling unit rooms shall have properly installed floor drains. For this application, we have chilled water supply and chilled water return. Coils in the air handling unit typically have to be maintained. During maintenance, you may have drain down procedures, and you need a floor drain properly installed in the air handling room to provide routine maintenance that may need drainage as well. Additionally, there may be condensate drainage to pipe into the floor drain as well from the evaporators that may be installed within air handlers in air handling rooms. Section 2.9.2.3, item E, gives us the requirement for access regarding roof or exterior wall installations. Item E1 indicates equipment installed on the roof or on an exterior wall shall be accessible under all weather conditions. A portable ladder or other portable temporary means may be used for access to equipment located on the roof or on exterior wall of a single-story portion of the building. Item E2, platform. When the roof has a slope greater than 4 in 12, a level working platform at least 750 millimeters in depth shall be provided along the control or service sides of the unit. Sides of a working platform facing the roof edge below shall be protected by suitable and substantial railing a minimum of 1 meter in height, with vertical rails not more than 525 millimeters apart, except that parapets at least 600 millimeters in height may be utilized in lieu of rails or guards. This section clearly indicates that when we have a roof slope greater than 4 in 12, we need a level working platform to be constructed around and at all service sides of the unit, as well as control sides of the unit, for the safety of personnel working on that particular unit. We also have to have installed a railing of 1 meter in height with vertical rails not more than 525 millimeters apart. This is to prevent falls and fall protection for the service personnel working on the equipment or appliances on this roof accordingly. Item E3, catwalk. On roofs having slopes greater than 4 in 12, a catwalk at least 400 millimeters in width with substantial cleats spaced not more than 400 millimeters apart shall be provided from the roof access to the working platform at the appliance. This section clearly states, ladies and gentlemen, that you cannot walk on a roof that has a slope greater than 4 in 12. Therefore, we need to get from the roof edge to the platform of this steeply sloped roof by means of a catwalk. A catwalk is a level walk that would allow the service personnel to walk from the edge of the roof to the platform that's required when we have roof slopes greater than 4 in 12. It's very common that HVAC equipment and appliances will be designed and installed on normally flat building rooftops. However, access to these appliances can usually be provided by means of a portable extension ladder when building heights are low and roof slopes are not more than 4 in 12. The example below shows an air conditioning unit on a sloped roof with a service platform and guards. As we can see here, this particular example gives us a slope of 3 in 12. Therefore, the service personnel can provide a portable ladder at the edge of the roof, climb onto the roof, and up to the platform. The platform must have 750 millimeter as a minimum to provide working access to the service side and control side of the appliance. Additionally, guards are required, and the guards have to have a minimum of 900 millimeter and a maximum of 1050 millimeter above the surface accordingly. Chapter 2, Section 2.11.4, Mechanical Exhaust. This section gives us requirement regarding mechanical exhaust systems. Section 2.11.4.1, where required. All rooms and areas having air with dust particles sufficiently light enough to float in the air, odors, fumes, spray, gases, vapors, smoke, or other noxious or impurities such as quantities as to be irritating or injurious to health or safety, or which is harmful to building and materials or has substances which create a fire hazard, and rooms or areas as indicated in Table 8.2.6 shall have their air exhausted to the outdoors in accordance with this section. Now, the primary intent of this section, section 2.11.4.1, is to provide requirements for connections and discharge locations of exhaust systems. The air removed by every mechanical exhaust system shall be discharged outdoors at a point where it will not cause a public nuisance. We need to capture the odors, the fumes, the spray, the gases, smoke within certain areas of our building and discharge them accordingly to the outdoor atmosphere. This section gives us the initial requirement for mechanical exhaust systems. Section 2.11.4.1, where required, all rooms and areas having air with dust particles sufficiently light enough to float in the air, odors, fumes, spray, gases, vapors, smoke, or other noxious or impurities in such quantities as to be irritating or injurious to health or safety, or which is harmful to building and materials, or has substances which create a fire hazard in rooms or areas as indicated in Table 8.2.6, shall have their air exhausted to the outdoors in accordance with this section. Indicating the table off to the right-hand side, Table 8.2.6 gives us the requirements for the minimum air circulation rate for mechanical ventilation and non-air conditioned spaces. As seen in the table, we have the application column that describes the area within the building. To the right of that, the next column indicates the air changes per hour. The minimum amount of circulation rate for ventilation is to be determined based on the occupant load, space, area, and use of the building in accordance with this table. The air circulation rate specified in this table shall be equal to the combined total of outside air and recirculated air. The occupant load shall be determined in accordance with the data provided in Table 8.2.3. Table 8.2.3 is titled Minimum Ventilation Rates for Air-Conditioned Spaces. As seen here, the table gives us much information about the occupancy classification, airflow rates, and in the very last column, there's an exhaust airflow rate as well. This table, Table 8.2.3, is based on ASHRAE 62.1, called the Ventilation Rate Procedure. This table prescribes both the use of 100% outdoor air as ventilation air and an occupant load calculation method for ventilation purposes only. The occupant load utilized for the design of the ventilation system must not be less than the number determined from the estimated maximum occupant load rate indicated in Table 8.2.3. Ventilation rates for occupancies not represented in Table 8.2.3 shall be those for a listed occupancy classification that is most similar in terms of occupant density, activities, and building construction, or shall be determined by an approved engineering analysis. See specialty shops in the occupancy classification for beauty and nail salons. In Table 8.2.3 below, in the specialty shop category, beauty and nail salons. Note H at the end of this particular table addresses nail salons and requires a source capture system for each nail table or station, in addition to the other requirements for ventilation and exhaust in this particular table 8.2.3. The reason for this particular table in our exhaust discussion is that Note H assigns a minimum exhaust airflow rate. As seen at the bottom of the table, Note H indicates the following. For nail salons, the required exhaust shall include ventilation tables or other systems that capture the contaminants and odors at their source and are capable of exhausting a minimum of 25 liters per station, 25 liters per second per station. That is, every nail table or nail station must have a minimum exhaust airflow rate of 25 liters per second. As an example, a source capture system. Indicated on the right-hand side of the slide, we have what's called a nail table. As you can see, we have a downdraft face and baffle. This is the point that the contaminants need to capture the application. The air is flowing downward into the blower, as can be seen in the lower right-hand side of the slide. The contaminants enter the centrifugal fan and are discharged to the outside effectively. This is a nice source capture system that fits the application. At each nail station, a source capture system must be capable of exhausting not less than 25 liters per second per nail station. And we found that requirement in Note H of Table 8.2.3. The exhaust from a station in a nail salon is required to capture the air contaminants at their source and effectively terminate them to the outdoor atmosphere. The source capture system must provide a source capable of exhausting a minimum of 25 liters per second per station. Nail stations can be manufactured by a tabletop intake arrangement specifically designed for this application, or simply be supplied with an overhead intake hose arrangement or duct arrangement that consists of a movable hose or duct or tube placed at the source of the contaminant. Figure 1.5 and Figure 1.6 illustrates both of these applications. As seen in Figure 1.5, this is a tabletop intake exhaust arrangement. At the work area shown on the tabletop, this is where we would get a minimum of 25 liters per second per nail station. As shown here, we have an inline fan that draws air through the inline fan and directly to the outdoors. Figure 1.6 gives us another application of where we have a duct, a flexible duct, that is placed on the work area, a manicure table. This would be the source capture area. The customer would place their hands on top of the table, and the contaminants would be captured at the source. At the source, we need again 25 liters per second right at that location. The contaminants would be exhausted up that flexible duct into the inline fan and exhausted completely to the outdoors. Section 2.11.4.2, Design of Exhaust System. Item A gives us a general requirement. The design of the system shall be such that the emissions or contaminants are confined to the area in which they are generated by currents, hoods, or enclosures and shall be exhausted by a duct to a safe location or treated to remove contaminants. Ducts conveying explosives or flammable vapors, fumes, or dust shall extend directly to the exterior of the building without entering other spaces. Exhaust ducts shall not extend into or through ducts or plenums. Item B, exhaust air inlet. The inlet to the exhaust system shall be located in the area of heaviest concentration of contaminants. The primary intent of this section is to properly capture emissions or contaminants and convey them safely to the exterior. Exhaust ducts are not permitted to extend into or through ducts or plenums in order to prevent the introduction of contaminants into the air distribution system. The general provision in item A gives us very specific information whereby we have currents, hoods, or enclosures. We need to exhaust these capture equipment devices by means of a duct system to a safe location. Section 2.11.4.5 is titled Exhaust Outlets. This gives us requirements for termination points regarding exhaust ducts discharging to the atmosphere, and these discharge points shall not be less than the following. Item A, ducts conveying explosive or flammable vapors, fumes, or dust. We need to be at least 9 meters from the property line, 3 meters from openings into buildings, 2 meters from exterior walls or roofs, 9 meters from combustible walls or openings into the building which are in the direction of the exhaust discharge, and 3 meters above the adjoining grade. Designing the locations of exhaust outlets and ducts conveying explosive or flammable vapors, fumes, or dust must be located to reduce such exposures that are indicated in this section. The separation from openings into buildings, walls, and roofs is to prevent recirculation of flammable vapors, fumes, or dust back into the building and contact with materials that may pose as sources of ignition. For ducts conveying explosive or flammable vapors, fumes, or dust, Section 2.11.4.5a requires the following minimum separation distances as indicated in Figure 1.8 below. If we look at this particular building, this building gives us the locations that our exhaust duct terminations must be at a minimum. If we look above the roof, we need to be at least 2 meters above the roof for our exhaust duct termination. From the side of the building, we need to be at least 9 meters away from the lot line. We need to be 3 meters above grade and 2 meters away from the wall. From the side indicated with the opening the operable opening on the left-hand side of the building. We need to be 3 meters minimum from the exhaust opening and 3 meters from any other building as seen here. You can see a combustible wall located adjacent from the main building with the exhaust duct termination. These are locations given to us graphically. Now, the authority must receive construction documents for mechanical exhaust systems. And on the construction documents, the engineer must indicate exactly where the terminations are going to occur. Now, again, if this is explosive or flammable vapor exhaust systems, or even fumes or dust, these are the minimum requirements that have to be maintained. The authority will approve the drawings if code compliance can be granted or shown on the construction documents. When the inspector goes out to the job site for the inspection of the exhaust systems, the inspector must make sure that according to the approved construction documents and this particular section, all of the minimum requirements have been met. In section 2.11.4.5, item B, titled Other Product Conveying Duct Outlets. Now, this is other products. This is not, I repeat, not explosive and flammable vapors. It is not fumes or dust. These outlets convey bathroom exhaust, things of that nature. The requirement is 3 meters from the property line, 1 meter from exterior walls or roof, and 3 meters from openings into the buildings, and 1 meter above the adjoining grade. Again, this is for other product conveying duct outlets. Item C gives us the requirement for domestic kitchen bathroom exhaust duct outlets with respect to domestic clothes dryers. If we have any of these domestic kitchen, bathroom, domestic clothes dryer exhaust ducts, the requirement is lessened. It goes to 1 meter from the property line and 1 meter from openings into the building. Other product conveying duct outlets is air that is conveyed to or from occupied areas through ducts that are not part of the heating and air conditioning system, such as ventilation for human usage. As seen here, we have domestic kitchen range exhaust that could possibly be considered, as well as bathroom exhaust and domestic clothes dryer exhaust. So depending on what type of exhaust the engineer is designing, we need to see exactly where the termination points are based upon the type of exhaust system that is being designed. In general, air that is exhausted from occupied areas for human usage, such as bathroom exhaust, domestic kitchen range exhaust, and domestic clothes dryer exhaust, are not considered to be hazardous or noxious. Therefore, Section 2.11.4.5b requires minimum separation distances for other product conveying duct outlets indicated in Figure 1.9 below. As seen here, we have a building that is conveying other product conveying ducts. It does not convey explosive or flammable vapors, fumes, or dust. Therefore, we are given a less stringent requirement. As seen here, if we look on the roof of the building, our duct conveying other product conveying ducts, such as ventilation air perhaps, only has to be 1 meter above the roof. On the side of the building facing the lot line, we only have to be 3 meters away from the lot line. And the elevation above grade is 1 meter at a minimum. And we have to be 1 meter away from the walls. On the side of the building, adjacent to the operable opening, you can see that we have to have a 3 meter minimum separation. And again, the elevation above grade is 1 meter. Section 2.11.4.6, Motors and Fans. Item A gives us general requirements regarding motors and fans to be sized, provided that the requirement of air moved in these systems is designed accordingly. Motors in areas which contain flammable vapors and dust shall be of a type approved for such environments. A manually operated remote control device shall be installed to shut off fans or blowers in flammable vapor or dust systems. Such control device shall be installed at an approved location. Now, the electrical equipment used in these operations that generate explosive or flammable vapors, fumes, or dust shall be interlocked with the ventilation system, so that the equipment cannot be operated unless the ventilation fans are in operation. Motors or fans used to convey flammable vapors or dust shall be located outside the duct and shall be protected with approved shields and dust proofing. Finally, motors and fans shall be accessible for servicing and maintenance. So the key requirements here that we have to make note of is the interlocking controls will ensure that the equipment involved in operations generating the explosive or flammable vapors or even fumes or dust will not function if there is insufficient ventilation or exhaust to evacuate these contaminants. The controls must be interlocked to prohibit the operations of the equipment that generate these contaminants. The type of air-moving equipment must be carefully considered when designing an exhaust system to handle the flammable or explosive substances as well. Now, the very last item that we need to pay attention to as well is any motors or fans that are used to convey flammable vapors or dust, things of that nature, must be approved. And shields and dust proofing, the motors and fans also need to be accessible for servicing and maintenance. Part B of Section 2.11.4.6 indicates requirements for fans. As such, parts of fans in contact with explosive or flammable vapors, fumes, or dust shall be of non-ferrous or non-sparking materials, or their casing shall be lined or constructed of such material. When the size and hardness of materials passing through a fan could produce a spark, both the fan and the casing shall be of non-sparking materials. This is important because we are conveying explosive or flammable vapors, perhaps, given an application of a particular exhaust system. We do not want an ignition source. Continuing on with the requirement, it indicates where fans are required to be spark resistant, Their bearings shall not be within the airstream, and all parts of the fan shall be grounded. We don't want any type of high temperatures resulting in a bearing failure that would create a hot surface and possibly ignite flammable or explosive vapors or dust or even fumes within the airstream. That's why we have this particular requirement. Moving on, it indicates that fans in systems handling materials that are likely to clog the blades and fans in buffing or woodworking exhaust systems shall be of the radial blade or tube axial type. Further, equipment used to exhaust explosive or flammable vapors, fumes, or dust shall bear an identification plate stating the ventilation rate for which the system was designed. Very important here that the system must be designed to convey at an airflow rate to exhaust properly the flammable vapors, fumes, and dust, and thus this requirement provides an identification plate stating the ventilation rate as such. Fans located in systems conveying corrosives shall be of materials that are resistant to the corrosion or be coated with a corrosion-resistant material or materials. A concern required by this section is the possibility of mechanical exhaust equipment being an ignition source in systems handling explosive or flammable materials. Additionally, we read that abrasive exhaust materials, such as those produced by cutting, maybe grinding, milling, and forming stock materials, can produce sparks while passing through the exhaust system. This section is given to us for specific requirements regarding fans and parts of fans regarding this environment. Section 2.11.4.8 titled Exhaust System Ducts. Item A, Construction Requirements. Ducts for exhaust systems shall be constructed of materials approved for the type of particulates conveyed as per the latest standard in this regard. Ducts shall be of substantial airtight construction and shall not have openings other than those required for operation and maintenance of the system. In other words, our duct construction must be tight and constructed along with designed for the particulates that must be conveyed through that duct. Item B, supports. Spacing of supports for ducts shall not exceed 3.7 meters for 200 millimeter ducts and 6 meters for larger ducts unless justified by the design. The design of the support shall assume that 50% of the duct is full of the particulate being conveyed. This will allow the supports to be designed accordingly by the engineer. As referenced by this section, additional performance aspects of ductwork relating to the construction, such as the installation, dimensional and structural stability, leakage control, as well as thermal performance, durability, support, vapor permeance, and airflow resistance must also be considered depending on the type of exhaust system that's being designed and constructed. We must also be aware of properly supporting the exhaust ducts, not exceeding 3.7 meters for 200 millimeter ducts and 6 meters for larger ducts. As seen here on the right-hand side, the graphic, proper support is required and we are given a maximum spacing interval according to this particular section. So as inspectors out in the field, we must verify that the ducts have been constructed of approved materials as designed and the spacing of supports do not exceed the maximum intervals provided in this particular section. Section 2.11.4.7 Exhaust Systems of Special Areas. Item A gives us a special area titled Motor Vehicle Operation. The requirement is in areas where motor vehicles operate for a period of time exceeding 10 seconds, the ventilation return air shall be exhausted. However, in fuel dispensing areas, the bottom of the air inlet or exhaust opening shall be located a maximum of 450 millimeters above the floor. Now, this is to prevent the accumulation of harmful contaminants. These spaces must have mechanical ventilation as prescribed in Table 8.2.3. For example, in Table 8.2.3, it specifies an exhaust rate of 7.5 liters per second for repair garages, and Note B of Table 8.2.3 specifically requires all air supplied to such spaces shall be exhausted, including any air in excess of that required by this table. It should be noted that Note B does not permit the recirculation of the minimum required amount of ventilation air to any other occupancies. In addition to mechanical ventilation being required for repair garages, a source capture system may be designed where stationary motor vehicles operate. This is an inlet to the exhaust system that can be moved to a location of a vehicle exhaust pipe or pipes to capture the heaviest concentration of contaminants as required by Section 2.11.4.2 Item B. Figure 1.7 below shows an overhead source capture system designed to be placed over vehicle exhaust pipes. The system must either be designed by an engineer or must be factory built, that is designed and sized for the intended purpose. These systems are typically used in commercial repair garages and essentially capture the contaminants and exhaust them completely outside of the building. As seen in Figure 1.7, we have a flexible hose or duct that actually gets pulled down and placed over the exhaust pipe. The metal duct that comes out from the center of the roll or the reel is directed upwards, up through the roof of the building, and exhausts all the contaminants to the atmosphere outside of the building. Last, the mechanical exhaust also requires an approximately equal amount of makeup air to be provided as required in Section 2.11.4.3. That particular section indicates that makeup air needs to be provided to replenish the air that's exhausted by the ventilation system. In this case, it's an exhaust system. We still need to replace the amount of air that's being exhausted by this particular system. Makeup air intake shall be located so as to avoid any recirculation of contaminated air within the enclosure. So now we have a special type of an exhaust system, a source capture system, and the requirement for makeup air. Section 2.11.5.1 addresses the requirements regarding kitchen exhaust ducts. Item A describes the requirements for the materials that are utilized for kitchen exhaust ducts and plenums. They shall be constructed of at least 16 gauge steel or 18 gauge stainless steel sheet. Joints and seams shall be made with a continuous liquid tight weld or brazed made on the external surface of the duct system. In addition, a vibration isolator connector may be used, provided it consists of non-combustible packing in a metal sleeve joint of approved design. Due to the fact that we have high temperatures being conveyed through these kitchen exhaust ducts, mandates the non-combustible packing in the isolator vibration connector. Figure 1.8 provides an example of 16 gauge sheet metal commercial exhaust duct welded continuous for a liquid tight seal as indicated in the picture below. The authority may alternatively approve listed and labeled factory-built grease ducts. Shown below is an example of a factory-built grease duct system that is listed and labeled in accordance with UL 1978 for zero clearance to combustibles. Section 2.11.5.1 Materials Continued, item number A. Duct bracing and support shall be of non-combustible material, securely attached to the structure and designed to carry gravity and lateral loads within the stress limitations of the building code. This is important because this requirement allows the designer to properly design the load carrying capability of all supports for the duct based upon the application, and also it must carry the lateral loads within the stress limitations of the building code. Bolts, screws, rivets, and other mechanical fasteners cannot penetrate the duct walls. Exhaust fan housing shall be constructed of steel. The exception to this particular item A is when we have kitchen exhaust ducts which are exclusively used for collecting and removing steam, vapor, heat, or odor may be constructed as per the provisions of section 2.4.1. The ducts are permitted to be constructed of thinner materials according to this section 2.4.1 due to the omission of grease and smoke and elevated temperatures as well, while exhausting contents, of course, with lower temperatures. Corrosion protection is given in item B. Ducts exposed to the outside atmosphere or subject to a corrosive environment shall be protected against corrosion. Galvanization of metal parts, protection with non-corrosive paints, and waterproof insulation are considered acceptable methods of protection. As we move to item C for kitchen exhaust ducts, this section covers requirements regarding prevention of grease accumulation within ducts. Duct systems shall be so constructed and installed that grease cannot become pocketed in any portion thereof, and the system shall have a slope of not less than 1:48 towards the hood or an approved grease reservoir. Where the horizontal ducts exceed 23 meters in length, the slope shall not be less than 1:12. This particular section reinforces the fact that we need to have drainage back towards the hood or an approved grease reservoir to allow the grease to run down and be collected at an approved location. Commercial kitchen exhaust ducts conveying grease and smoke must be constructed with the code prescribed slopes as indicated in this section, again, without forming any kind of dips or low points in the ductwork that are capable of collecting grease or residue. The duct systems must slope not less than 1 unit vertical in 48 units horizontal toward the hood or toward a grease reservoir. The slope must not be less than 1 unit vertical in 12 units horizontal when the ducts exceed 23 meters in length. Grease duct slope example. A commercial grease duct system is shown below, sloping not less than 1 unit vertical in 48 units horizontal towards a grease reservoir. As indicated in the bottom image, we can see that the duct is sloping in both directions from the left to the right to a grease reservoir. As indicated in the graphic, the ducts are not more than 23 meters long, and they are pitched towards a grease reservoir. The top graphic indicates a grease reservoir. The grease reservoir has been designed in this particular application as being 300 millimeters minimum and a minimum of 25 millimeters from the point of the drop below the horizontal duct to start the slope to the drain plug outlet. This way, this allows a low point in the ductwork that's accessible for cleaning purposes and extraction of any grease residue that may slope back into this low point of the ductwork. This is important because it is allowed by the previous section to have the duct slope either towards a hood or this particular device called a grease reservoir. Item D is air velocity. The velocity in the duct shall be a minimum of 7.62 meters per second and a maximum of 12.7 meters per second. This allows the designer, of course, to pick a range based upon the application as a minimum and maximum for the design. Item E, cleanouts and other openings. Duct systems shall not have openings other than those required for proper operation and maintenance of the system. Any portion of such system having sections inaccessible from the duct entry or discharge shall be provided with adequate cleanout openings of approved construction, spaced not more than 6 meters apart. The cleanout shall be located on the side of the duct having a minimum opening dimension of 300 millimeters or the width of the duct when less than 300 millimeters. Section 2.11.5.1.d provides a minimum and maximum design velocity range that the engineer is to design the exhaust system to keep the grease and smoke particles in suspension and convey them safely through the ductwork and discharge to the outdoors. Grease can then and also will liquefy in the duct. Therefore, the cleanout requirement in any portion of the grease duct is required. The duct system that cannot be reached, however, for cleaning and inspection from the grease duct entry or discharge is required to be spaced not more than 6 meters apart. Grease ducts that are inaccessible from the hood and discharge openings, of course, are mandated to be at this particular 6 meter interval and nothing greater. An example of the cleanout spacing is indicated below. Duct systems shall not have openings other than those required for proper operation and maintenance of the system. Any portion of such system having sections inaccessible from the duct, entry, or discharge shall be provided with adequate cleanout openings of approved construction spaced not more than 6 meters apart. As seen below, we have a hood that captures grease and smoke and draws it up through filters before it enters the duct. The spacing of the cleanouts are 6 meters maximum. At this interval, it meets the code requirement and is in compliance. A little detail indicates the minimum opening dimension of 300 millimeter or the width of the duct when less than 300 millimeters. If the duct is of adequate size, the duct cleanout opening will be a minimum of 300 millimeter by 300 millimeters. Item G indicates that the kitchen exhaust airflow rate shall be calculated based on the data provided in Table 8.2.8. Now this table, as indicated below, provides a designed exhaust airflow rate regarding electric and gas equipment. The first column indicates the number of the equipment. The second column indicates the type of kitchen equipment. The third column gives the electricity-based equipment value. And the fourth column gives us the gas-based equipment value. Those values are in liters per second per kilowatt of the kitchen equipment. As an example, a 12 kilowatt electric griddle would require a maximum exhaust flow rate of 384 liters per second. That's given the electricity-based equipment at 32 liters per second per kilowatt of appliance equipment. As seen below, 32 liters per second per kilowatt per 12 kilowatt would equate to 384 liters per second. Kitchen exhaust hoods are given to us here as a requirement in section 2.11.5.2. Item A, a commercial kitchen exhaust hood shall be provided for each commercial cooking appliance. There are some exceptions, however. The exceptions are an appliance located within a dwelling unit and not used for commercial purposes. Number 2, completely enclosed ovens. Number 3, steam tables. And finally, number 4, auxiliary cooking equipment that does not produce grease-laden vapors, including toasters, coffee makers, and egg cookers. So this particular section lends itself to provide requirements for grease-laden vapors based upon certain cooking operations and commercial cooking appliances. Item C gives the requirements for hood construction. The hood is required to capture these grease-laden vapors. The hood and other parts of the primary collection system shall be constructed of galvanized steel, stainless steel, copper, or other material approved by the building official for the use intended. The minimum nominal thickness of the galvanized steel shall be 1.2 millimeter or 18 gauge sheet steel. The minimum nominal thickness of stainless steel shall be 0.93 millimeters or 20 gauge sheet steel. Hoods constructed of copper shall be sheets weighing at least 7.33 kilogram per square meter. All external joints shall be welded liquid tight, and hood shall be secured in place by non-combustible supports. As indicated below is an example of stainless steel kitchen exhaust hood, and the minimum thickness of this hood is in fact 20 gauge sheet steel. Section 2.11.5.2 Item D, Interior Surface, describes the requirement for the interior surfaces of a hood in that they shall not have any areas that accumulate grease. The exception is grease collection systems under filters and troughs on the perimeter of canopy hoods. Item E, canopy hoods shall be designed to completely cover the cooking equipment. In other words, they have to overlap the cooking appliances. The edge of the hood shall extend a minimum of 150 millimeters beyond the edge of the cooking surface. That's horizontally, as well as the maximum vertical distance between the lip of the hood and the cooking surface shall not exceed 1.22 meters. This is designed such that it allows the cooking effluent, the fumes, the grease, the smoke, and other particulate matter to be captured by the canopy hood. In other words, it overlays beyond the cooking equipment to properly capture the contaminants within the hood. Grease removal is given to us in section 2.11.5.4. When we capture the grease-laden vapor into the hood, we direct it through a filtration system. These are metal filters with mesh normally. The air exhausted in every commercial exhaust hood shall pass through approved grease filters or grease removal device designed for the specific purpose. Grease removal devices shall bear the label of an approved agency and shall be installed in accordance with the manufacturer's instructions for the labeled equipment. All grease filters shall be accessible. Grease filters shall be installed at a minimum angle of 45 degrees to the horizontal. The filters shall be arranged so as to capture and drain grease to a point of collection. As indicated in the picture below, we can see a series of grease filters installed at an angle of 45 degrees within a metal type hood. To the right is a section view indicating the 45 degree or greater angle from the horizontal, and as grease would accumulate in the filters, it would have a way to drain downward into the intercepting devices, which is a channel that goes completely along the hood itself towards the back part of the hood and dumps into a collection cup on the far end of the hood, as can be seen in the picture on the left-hand side. Motors, fans, and safety devices are given to us in section 2.11.5.5. Item A, motors and fans shall be of sufficient capacity to provide required air movement. Electrical equipment shall be approved for the class of use as provided in the code. Motors and fans shall be accessible for servicing and maintenance. This is so important regarding these type of systems. Motors of the exhaust fan shall not be installed within the ducts or under hoods. Item B, commercial exhaust system hoods and ducts shall have a minimum clearance to combustibles of 450 millimeters. An example of a commercial exhaust system hood where the back edge is in contact with a non-combustible wall. This particular hood installation would not have to meet any clearance requirements as indicated above due to the fact that it is a non-combustible wall. As you can see here, it's a concrete masonry unit wall which is considered non-combustible. Fire suppression system is required by item C of this section. All commercial cooking surfaces, kitchen exhaust systems, grease removal systems, and hoods shall be protected with an approved automatic fire suppression system as per the code. Indicated below is showing a suppression system with nozzles and a control panel and storage cabinet accordingly based upon the commercial cooking appliances underneath the hood. This is the end of the presentation. Thank you for your participation.